Hello everyone, I hope you all are doing great. Today we will cover questions of pneumatic system from Smart Cockpit. I will discuss each question with you and give you explanation from FCOM. So let's start. Disclaimer, I do not own any of the image and content used in this course. All of it is just taken from Airbus manuals just to serve the purpose of easier understanding. I do not recommend any practical application in real world. And please you can use 1.5 or 2x because my rate of speech is very low, and do not expect any uh, great teaching skills or editing skills in my video because I'm not a YouTuber. I'm not a teacher. So so start it. So pneumatics. First question from Smart Cockpit is engine bleed air temperature is controlled by engine oil, pre-cooler that uses fan air, or conditioned air from mixing unit. Definitely pre-cooler that uses fan air. As I have told you, air comes from here, IP or HP section, and then it goes to the pre-cooler, and pre-coolers cools air down to 200 degrees Celsius. Hence option is pre-cooler. If BMC1 fails, BMC takes over all monitoring functions. Yes, BMC2 takes over, another BMC takes over in case of any BMC failure. Only monitoring functions, but do not take care of leak detection of engine 1 and APU. That is a fact. So option A. Bleed air normally comes from the intermediate stage. Option Bravo. Intermediate stage serves the bleed air, but in case of insufficient bleed then or at very low RPM, engine RPM, then HP serves this uh, serves the bleed from engine. But in normal case, in normal situations, IP serves this. Question number 4. In flight, if the air pressure is insufficient enough even with the HP valve open, so engine spools up automatically. Here the question is, if this IP is unable to serve bleed system, then automatically bleed air from HP is taken. But even after using HP, the demand is not served, then engine spools automatically. So this is the case. Question number 5. The pressure regulating and shut-off valve will close if, now as I have told you, if upstream pressure is low or the reverse airflow is detected, the pressure regulating or shut-off valve automatically close. So this pressure regulating shut-off valve closes automatically if upstream air pressure is low or reverse flow is detected. This bleed valve will close automatically if pressure here in this area is detected low compared to this section. Technically there should be high pressure and there should be low pressure. That's why air will flow, like bleed air will go from here to here. But if reverse occurs, then this bleed valve automatically closes. So option Charlie. The cross bleed valve has two electric motors, one for automatic mode and one for manual mode. That is true. I have told you this cross bleed valve. This cross bleed has two electric motors, one for automatic control and one for your manual control. That's a fact. The overheating detection uses the single loop. Yes, for pylon and APU. I have told you this while explaining FCOM. We have single detection loop for pylon and APU, and for wings we have dual loop. The APU bleed fault light illuminates amber in case of bleed leak. So they are talking about, let me show you. APU bleed light. They are talking about here APU bleed fault light comes when bleed leak is detected. The auto position of the cross bleed selector opens the cross bleed if APU bleed valve is open. Option Bravo. Let me explain you. Although I have explained during FCOM explanation. Let's say we have kept this selector, bleed selector to auto. So what happens is when we have kept it in auto, just a second, when we have kept it auto, so the APU and the APU bleed is taken. Let's say APU is supplying bleed air, so cross bleed valve will open and will supply to the both side, and the bleed air will be supplied to the both side. So if in case cross bleed remains closed, then what will happen? There will be no bleed supply to the right side. Of course you can figure it out by looking at this uh, schematic diagram. So if APU cross bleed is in auto and APU bleed is taken, the cross bleed valve opens automatically. Next question. You can keep this video at 1.5 or 2x because my rate of speech is very low. I'm asking you guys to do it if you find it very slow. The recirculation fan in the air conditioning system, we will discuss this question in AC, air conditioning. Temperature regulation, same, we'll discuss in AC. Should both channels fails in one zone, same, we will discuss in AC. Laboratory galley extract fan, ventilation. If bleed air is being supplied by the APU, or if one pack fails, then pack flow will go to high rate automatically. This is a fact and we have to accept it. Whenever APU is supplying bleed or any of the pack fails, automatically high rate will be supplied to the system. So irrespective of this switch, let me take a screenshot, and then irrespective of the position of this switch, rate will be high automatically if APU is supplying or any of the pack is fail. Next question. What happens to the outflow valve when the ram air switch is selected to on? Whenever ram air switch is selected to on, so which switch they are talking about? This ram air switch. whenever ram air switch is selected on, so ram air will be taken from outside, but outflow valve will open only and only if delta P is less than 1. When the pressure differential is less than 1 psi, then only outflow valve is open after pressing this ram air push button. I hope you are getting what I'm saying. When either the blower and extract, we will study this in ventilation, avionics ventilation. How many motors are available? There are 3 motors for outflow valve. This is uh, from cabin pressurization. Transfer between the two cabin CPCs, cabin pressure controllers, is automatically after landing. This is also in cabin pressurization. I am discussing only when questions of pneumatics, bleed air only. Maximum cabin rate is also 750 feet per minute. This is the maximum cabin descent rate in automatic operations. Let me tell you this one also in this video only. Transfer between two CPCs is controlled automatically after each landing, or in case of operating any of the controller fails, the operating controller fails, then automatically it shifts to another after I think 70 second when the speed is below 70 knots, I think. Okay, the third motor in the pressurization system is activated when the cabin pressure mode selector switch is positioned to man, Charlie. What third motor they are talking about in pressurization system? So let me discuss it with you. Okay, so there are two CPCs. They are CPC1, CPC2. Both are automatic. If any of the if any of the fails, another takes over automatically. But what if another fails? Then there is a third backup mode. This is manual. If this fails, then it shifts to shifts to second, and if second also fails, then we can use manual controls to control our pressurization, cabin pressurization. So where is the switch? This is the switch here in cabin pressurization. This is the switch, mode selector. We will press this mode selector switch and use this toggle. This is spring loaded. When we will keep it to up, the valve will open, and we will press it down, then valve will close, and vice versa. So these are the manual controls of cabin pressurization. This is the third motor they are talking about. When the cabin vertical speed exceeds when the cabin vertical speeds exceeds 1800 feet per minute, then the vertical speed display flashes green, Charlie. The pneumatic system supplies high pressure air to air conditioning, water pressurization, engine starting, wing anti-ice, A and B both, because this is high pressure air only, which is taken from either intermediate stage or high pressure stage. It is a high pressure air. Yes, all of the above, because Charlie option is also air, hydraulic reservoir pressurization. High pressure air has three sources. Option Bravo. We have engine bleed air, we have APU, and we have external unit also. So where it is written in the FCOM? Here it is. High pressure has three sources: engine bleed, APU load compressor, and HP ground connection. With both engines operating, the engine bleed push button fault light will illuminate when the valve position differ from the push button. We can find it where in controls and indicator of this chapter. You can go to the controls and indicator and check it. Air bleed from the engine is cooled in heat exchanger, not cooled prior to being used by the system. No, cooled, no, obviously, bravo. Cooled in heat exchanger by cooling air bleed from the fan section. So where it is, I have shown it again and again. Here it is. It is cooled in pre-cooler, and it is a air to air cooler. So air from the fan section, fan area is taken. Let me explain you in a better way. So air from this section is taken just to cool down the air which is sucked from IP or HP section of the engine. It is you have studied muffler type heat exchanger. This is kind of the same muffler type heat exchanger. It is air to air. Cold air is supplied and just to cool the outer part of this section of this system. Hmm. If a BMC fails, the remaining BMC will take over most of the functions, not all the functions. Another BMC just takes over just the monitoring functions. Leak detection system detects any overheating in the vicinity of hot air ducts. Yes, exactly. This is the function of leak detection system, and this is the principle of heat detection system. It detects overheating in the vicinity of hot air ducts only. If you are facing difficulties solving these questions, then you can refer to my another video in which I have explained a whole system from FCOM. When next question 28, when engine and wing anti-ice are in use and a BMC detects a bleed leak. So let me tell you, whenever leak is detected in wing anti-ice, then BMC can switch off or discontinue wing anti-ice, but not the engine pylon. The wing anti-ice is associated side will be lost and the engine anti-ice on the associated side will be continue to function. BMC do not have authority to switch off engine anti-ice. Next question. Each bleed valve is electrically operated and controlled pneumatically. No, that's wrong. Each bleed valve is pneumatically operated and electrically controlled. This is the catch. If a BMC detects a bleed leak, yes, whenever a bleed leak is detected, all valves that could supply pneumatic air to that area will automatically close. Option Bravo. No, option Charlie, all pneumatic valve will close automatically. No, not all automatic, not all valves, but that could supply pneumatic air to that area. That is the function of a bleed leak. No, that is how a bleed leak works. This function works. If one BMC fails, another BMC takes over most of the monitoring functions, monitoring things like overpressure, over temperature, or wing leak specifically, but not the APU leak and engine leak. Remember that question earlier? I think third or fourth question it was. So overpressure, over temperature, and wing leak, all of the above. If the option would be APU leak, then all of the above would not be the correct answer. APU bleed leak protection for the APU pneumatic duct is provided by bleed leak protection for the APU is provided by BMC1. So let me draw this thing. This is my aircraft and this is APU. BMC1, BMC1, BMC2. BMC1 controls left hand wing and APU, and BMC2 has this side. So detection loop associated with BMC1. APU APU doesn't have its own BMC, does not has its own BMC. Option Bravo, BMC2, no, BMC1. BMC1 controls left hand wing and APU. With the loss of pneumatic system pressure, the engine bleed valve will be in close position. Yes, it will be in close position. Whenever pneumatic system pressure is lost, the engine bleed valve will close automatically. This pneumatic system operation is controlled and monitored by two bleed monitoring computers, two BMCs. 55 ECAM bleed page, when is the ground symbol is displayed, whenever the aircraft is on ground. So how a bleed page looks like, this is the ECAM bleed page, and whenever the ground is written on it, it means the aircraft is on ground. In automatic mode, the crossbleed valve opens when the system is using APU bleed air, exactly, but if it closes if the system detects any air leak. Are you getting this point? Whenever it is in automatic mode and APU is supplying the bleed air, so cross bleed valve automatically opens. Cross bleed valve automatically, this valve automatically opens, cross bleed valve. But if any leak is detected, then it closes automatically. But there is a catch. If the engine is engine is starting, so it does not closes even if the air leak is detected, because engine is getting start now. Bleed is being provided to the engine also, and if the cross bleed automatically closes or cross bleed valve automatically closes, then engine will not be able to start. So option alpha. I'll try to get a PDF without marked answers so that it will be a little good for us. What happens when the pressure and the temperature are not sufficient to supply the corresponding engine bleed valve. What happens when the pressure and temperature are not sufficient to supply the corresponding engine bleed valve? So what happens whenever this whenever is not sufficient, then HP valve also opens and IP valve remains open. Initially system is taking bleed air from IP, getting, but if the bleed air is insufficient, then HP valves opens and system takes bleed from HP and IP both. Option Charlie. HP valves opens, IP stage remains in the same configuration, that is open. When additional pneumatic air is required for anti-ice, engine starting or air conditioning, additional pneumatic air will be requested by the BMC to the FADEC or the APU. When additional pneumatic air is required for anti-ice or engine starting or air conditioning, it will be requested by the BMC to the FedEx. So what FedEx will do, or what APU will do, FedEx will spool the engine to higher RPM, getting, and APU automatically provides high pressure only. Flow will be high if APU is supplying bleed air. 39. When selected APU bleed air, so let me tell you this thing I have told during FCOM explanation also, that APU bleed air has priority over engine bleed air. I have told you the priority order of bleed air while explaining the FCOM. When the APU running, with the APU running, the APU bleed push button selected to on and the cross bleed selected to auto. APU will supply pneumatic air to both sides of the aircraft because pneumatic cross bleed valve automatically opens. Again, the same concept I have told you. Cross bleed is on auto and APU is supplying the bleed. So cross bleed automatically opens so that the APU can supply, APU can supply to the whole cross bleed duct, left and right side both. Which source controls the cross bleed valve? Electric. Cross bleed valve is electrically controlled. The crew may directly control the following bleed valves. Crew has authority to control engine bleed valve, APU bleed valve, and let me show you. Engine bleed valve, APU bleed valve, or cross bleed valve. Here is the option: engine, APU, and cross bleed. Can you see? Engine, APU bleed valve, and cross bleed valve. This is the question. The crew may directly controls the following bleed valves. These are the only three valves a pilot can access directly. APU bleed air is supplied whenever APU speed is above 95%. That is a fact. Whenever APU is above 95% of its speed, of its RPM, then only bleed air is supplied. A check valve near the cross bleed duct protects the APU when bleed air comes from another source? True. So where is the check valve? Every question is you can solve every question by this schematic diagram only. The only hurdle I get is this. This is check valve. What this check valve do is it protects the whole system when the bleed comes from another source. We have so many other check valves also, other check valves also, like this. This is a check valve. This is a check valve. We have a check valve in IP to protect it from bleed coming from HP. Are you getting? Next question 45. Following an engine 1 bleed fall, why can you only use pack 1 if wing anti-ice is on? Because single engine cannot provide another pack and wing anti-ice both. So option bravo, only engine bleed system cannot supply two packs and wing anti-ice. Are you getting? Only single engine, any single engine bleed system cannot supply two packs, left or right both, and wing anti-ice. Temperature regulation is achieved by the pre-cooler, which regulates and limits the temperature at 200 degrees Celsius. Again the same schematic diagram. This pre-cooler cools air down to 200 degrees Celsius. I have written it down here also. So this schematic diagram solves your all questions, almost all questions. That's it. Now it's equipment. We'll do it some other day. Here your questions of smart cockpit ends. If